Welcome learners. Today we want to look at the carbon and its compounds. We begin by looking at the allotropes of carbon. First of all, divide the term allotropes and the term allotropy. Allotropy is existence of an element in more than one form in the same physical state. Allotropes are different forms of an element existing in the same physical state. Now, carbon has got three types of forms. We have what we call pure forms, which include diamond and graphite. Impure form, which include amorphous carbon, e.g. charcoal, coke, coal. Then the last one we have what we call synthetic carbon, which include fullerene. Now next we want to look at the differences in properties of diamond and graphite. First, we started by looking at diamond. Property number one is hardness. Diamond is very hard. Reason: due to uniformity of strong covalent bonds between carbon atoms throughout the giant's atomic structure. Property number two, conductivity. Diamonds do not conduct electricity. Reason: each carbon atom uses 4 valence electrons to covalently bond with other 4 carbon atoms, leaving no delocalized electron. 3. Density. Diamond has high density. Reason: due to continuous close packing of carbon atoms. Now the uses of diamond include: it is used as a jewel, e.g. necklace, rings, earrings. Reason: due to its shiny appearance when polished. 2. Used as a glass cutter and drill bits. Reason: because it is very hard. Now properties of graphite include: in terms of hardness, it is soft and slippery. Reason: it is made of layers. It is made of hexagonally arranged carbon atoms bonded together in layers which slide over each other due to weak van der Waals forces. In terms of conductivity, graphite conducts electricity. Reason: each carbon atom uses 3 valence electrons to covalently bond with other carbon atom, leaving 1 delocalized electron. Density: graphite has low density of 2.3 grams per centimeter cubed. Reason: due to spaces between the layers. Now uses of graphite includes: 1. It is used as a lubricant in moving machine parts. Reason: because it is soft and slippery, and also it has high melting and boiling point, which can make it withstand high temperatures of moving parts. 2. Graphite, when mixed with clay, is used to make pencil leads. Reason: the carbon layers can slide over each other due to weak van der Waals forces. Number 3. Is used as a positive electrode in dry cells and as electrode in industries. Reason: due to presence of delocalized electrons. The last one is used in making molds for casting metals. Reason is due to high melting and boiling point. Now, next we want to look at is examples of amorphous carbon and how they are formed. One is wood animal charcoal. Is formed when bonds are heated in limited supply of air. Wood charcoal is formed when a solid is left when wood is burned in limited supply of air. Sugar charcoal is formed by dehydrating glucose using concentrated sulfuric acids. Coke is formed when a solid is left. It is a solid left when coal is heated in the absence of air. Soot is formed when there is incomplete combustion of fuels. Now next we want to look at is the chemical properties of carbon. Number 1 is reaction with oxygen. Carbon burns in air to form a mixture to form two types of oxides. It forms carbon 4 oxide in excess oxygen and carbon 2 oxide in limited oxygen. Observation made is carbon glows red. Carbon glows red when heated in air. Reason: because the reaction between carbon and oxygen is exothermic. Equation for the reactions: carbon plus oxygen, arrow, carbon 4 oxide. This one you have excess oxygen. Carbon plus oxygen limited, arrow, carbon 2 oxide. Balance the equation, place 2 which is carbon and 2 which is carbon 2 oxide. Now 2, reducing property of carbon. Now carbon is able to remove combined oxygen in metals, e.g. zinc, copper, iron and lead. Example 1, a reaction between carbon and lead 2 oxides. Equation is carbon plus lead 2 oxide, arrow, lead plus CO2 gas. Observation made during the experiment is yellow lead oxide changes to grey. After the experiment, a grey solid is formed. Reason: carbon reduces lead 2 oxide to lead while itself is oxidized to carbon 4 oxide. Example 2, action of each carbon and copper 2 oxide. Equation is carbon plus copper 2 oxide, arrow, copper plus carbon 4 oxide. Observation made during the experiment: black copper 2 oxide changes to brown. At the end of experiment, brown solids formed. Reason: carbon reduces copper 2 oxide to copper while itself oxidized to carbon 4 oxide. Example 3, carbon and zinc oxide. Equation: zinc oxide plus carbon, arrow, zinc plus carbon 4 oxide. Observation made during experiment: white zinc oxide changes to grey. After the experiment, a grey solid is formed. Reason: carbon reduces zinc oxide to zinc while itself get oxidized to carbon 4 oxide. Example 4, reaction between carbon and iron 3 oxide. Equation: iron 3 oxides plus carbon, arrow, iron plus carbon 4 oxides. Observation made during experiments: brown iron 3 oxide changes to grey. After the experiment, a grey solid is formed. Reason: carbon reduces iron 3 oxides to iron while itself get oxidized to carbon 4 oxide gas. Now the last property is reaction with concentrated acids. The first one is reaction with concentrated nitric 5 acids. The equation is carbon plus nitric 5 acid, arrow, carbon 4 oxide plus nitrogen 4 oxide plus water. Observation made during the experiment: black solid dissolved in the acid, brown fumes are formed. Reason: carbon reduces nitric 5 acid to nitrogen 4 oxide and water while itself get oxidized to carbon 4 oxide. Example 2, reaction with concentrated sulfuric 6 acid. Equation is carbon plus sulfuric 6 acid, arrow, carbon 4 oxide, sulfur 4 oxide plus water. Now observation made is black solid dissolved the acids, bubbles of a colorless gas is seen. Reason: carbon reduces sulfuric 6 acids to sulfur 4 oxide and water while self oxidized to carbon 4 oxide gas. Learners, at the end of the lesson, the next lesson we're going to look at carbon 4 oxides. lesson 1.